I think this is like probably everything I can speak Finnish. I know today is a bit like a vähän piljonen päivä, but I think it would be enough for my drones to fly. Let me ask you a quick question, please. How many of you have got drones? Okay, at least you got some drones, yes. This is very nice. You know, over the last 10 years, drones became a commodity. 10 years ago, you can see drones flying over like Iran, Iraq, Afghanistan, Syria, just bombing things or taking information. But nowadays, you can see those drones. The kids from neighbor will be flying over your piha, sometimes crashing your like autobike, you know. But well, it's happened. It's became commodities. When people are stepping into my office, they tell me like, "You're a lucky person because you've got drones." I have to pay hundreds of euros to buy a drone, and then hundreds of euros to get spare parts. But you've got your hobby, part of your job, and you are paid for this. Well, this is what I like. My topic of today is how we're going to use drones for business. Let me just jump here. I've been running like R&D center for the last couple of years, 2 or 3 years, and we decided to make a R&D center on predictive analytics. Analytics means you take data from everywhere. And it could be in financial services, it could be in telecommunications, in defense, security. But what we try to do, we try to get like another angle. We try to bring in data which were not available before, which means you're flying drones, you're capturing images, you're capturing video, and then you work with this data. So we bring like a new angle to your business. And for the last 2.5, 3 years, our team, we claim about 25 to 30 different patents in computer vision technologies, deep learning, and analytics. The first solution which we may become available in the market is aerial monitoring solution. Use cases, I think they're very simple ones. You can see it easily for different industries. You've got cases for utilities. You make an inspection of power lines. You've got cases for oil and gas. You can make a detection of pipelines, oil spills, etc. You can get cases for mining, stockpile volume detection. You can get some ideas about, let's say, leakage. You can get estimations about what is going on your yard. Then another case for agriculture, forestry, agriculture, you can get detection of, let's say, health conditions of your vegetation. Railways, public transportations, military and defense, a lot of cases. In terms of benefits, the most benefits, you can see it like easily, because you got drones, and drones will be replacing people at some point of time, which means it becomes safer. One example, in South Africa countries, you got a client, and they got the pipelines which are crossing like the territory of 2 countries. They use helicopter flying over, let's say, every couple of weeks, every month, to make inspection. And one day, these aircraft crashed. People died. Is this a business case? Yes, definitely this is a business case. Another thing is, like, we've done also the project in Russia for Russian state grid. And we just make a very small test to prove this is feasible and doable and we can deliver results. And we use our partner flying above, you know, taking images. Then we take images and make a process, and then within 24 hours, we got results. And then we present the results to the client. And the head of maintenance team, he told us, this is amazing. It took you 24 hours to make a job of my team of 4 people, which normally took us about 2 weeks. You can make a comparison, trade-off. This is like how the process is of today for our aerial monitoring solution. First, of course, you've got drones, or we equip with any kind of sensors. It could be RGB cameras, it could be video cameras, it could be a laser scanner, it could be UV cameras, you know, you name it. Any of those sensors can be installed on UAV and used, and they can bring in information about different physical parameters of your objects. Then this data will be collected in the cloud, and then we apply our computer vision algorithms. We make an automatic detection of power lines, pipelines, oil spills, vegetation, and then we also take information and we build up a 3D model. 3D model will give information about, let's say, different physical parameters of your objects. How tall tree is, what is the length, etc. and then putting together information from computer vision masks with information from 3D models. You put it together and you feed it into your analytical engine. And then you start making comparison with historical data, with industry standards, or with client's requirements. And those reports are shared with the client. This example of a dashboard, operational dashboard, there is no need to watch like multiple thousands of images. Just give you some kind of understanding. If you fly and make inspection of 50 kilometers of pipeline, power line, you on average will get something like 11 to 13, 1,500 images. Like just imagine like 1,500 images, and you have to watch every image yourself. It will take you probably an entire couple of days. But the system will do it automatically within minutes or hours. And then the system will report to you those areas which are indicated in red. This is exactly what you're looking for. And then instead of checking images from entire power line or pipeline, you go to the cluster, you get information about specific ID, specific alarm, and you start digging into details. The system gives you a preview, opens up like a regional picture, and you say, okay, yes, this is a defect, verified, full stop. And just like another example, here we're checking the line sagging for power state grid, which is a very critical information. And our system in 3D model, we are building up a position of each individual line within the air, and then the system calculates the distance to the ground. And then the system will raise up a report when it's too low. Another case is detection of isolators, which becomes very common, especially it got a lot of interest from China, from Russia. People are going hunting. Sometimes when hunting is not very successful, they can seize the big isolators and like, okay, should I test my rifle? Okay, nice, no isolator. Then another example how analytics does work. For instance, you've got here your power lines, yes, I'm sorry. And then you've got inspection, which is going by his foot and checking like, how high vegetation is, how high trees are, What you see is only, say, front line, what you see. Line of sight is blocked with first trees. But what's going on behind, you have no clue. Just imagine you've got like another tree, which is tall enough. And if it will be like a strong wind, this tree can definitely break your lines. But you don't see it with your eyes. The same comes with another example. The line is crossing here. Lines are crossing a small farm. And the person was smart enough to build a storage place right under power lines. The distance is not so big. It's like 6.5 meters. Just imagine if the storage place is got under fire, it definitely will break your lines. And just like one example, like here, we got a map of individual tree with individual parameters, like a height, for instance. Where this information could be used. We got a case with our client in Indonesia. They've been running 500,000 hectares of forestry plantations. And what they've done is they want to understand, the quality of the forestry. They send inspector like every now and then, and they've got roughly, I think, 1,500 people working every day in the fields, and they could make sampling of 1 to 2% of entire territory within a year. And then they try to average out things, to get a ratio, how good plantation is, what is average yield, what is average height, etc. But this is not enough to make operational decision. You want to get understanding with a very high accuracy for entire plantation, for entire forestry. And this is what our solution has done. We used about a dozen of UAVs for a pilot. We covered area of 100,000 hectares. And we build up a map which shows you height of the trees, individual trees. It shows you density of trees. It shows you blank spots. And those blank spots, this is exactly the place where you would like to send your people to make inspection. Why? Because it could be like some strong hurricane came and break down some trees, or it could be, in worst case, a disease, and you don't want disease to start spreading out. This example, one person got in place, they make a picture, and you see exactly the blank spot as indicated by our map. And just for comparison, before and after, this like before our essential solution, this is after we deliver our pilot. Before, it took 2 guys 4 days to make analysis of 25 hectares, And 25 hectares, well, roughly they have 30 to 40,000 trees. After you make a processing, you will get information about million and a half trees, and it covers between 60 to 100,000 hectares, and basically it is done within hours. There's a big, big difference. Another thing now comes case from mining. For mining, very typical cases is leach pad inspection, basically when you dig out some kind of like chemicals, and chemicals should go through and take some very valuable parts with it. You know, you want the chemicals start working immediately to get as deep as possible. But you know, sometimes it stays. What is done today? They send a person. The person took like special uniform, like a very heavy chemical uniform, you know, and it goes on the top and makes inspection of those spots. Lengthy, dangerous, takes a person, you know. Making inspection by UAV, half an hour roughly. Same goes with making detection of stockpile volume. Today you've got laser scanner, and you can use it like with your foot. You can check like from 3 different angles, the same plot, you know. You build up a 3D model. You can use also the vehicle if you're allowed, you know, you can get around to make the same. But it's still, just imagine a yard, which contains, well, probably 15 to 25 different stockpiles. And it took you, Laza, probably a week, a half a week at least, just to make an inspection without getting numbers. UAV can do it much faster. We made the comparison, evaluation of one stockpile. When you're doing on food, it takes you normally, let's say, 2-3 hours to make inspection. Then you put data in the cloud, you calculate and get results. 5 to 6 hours for one plot. And in our case with UAV, it goes down to 1.5 to 2 hours. Basically, you speed up like 3 times your process. Another example could be, again, from mining. You can make inspection of what is going on inside, like combustion fire, you know, what is going on inside, internal fire. When you see it with your eyes, making visual inspection, you don't see anything that's happening here. But when you install thermal camera, the camera will see there is a heat. And you know exactly what's going on. Because next time you send excavation starts digging into place, oxygen flows in, and big fire comes out, boom. UAV can be used also before, after, and during the process of blasting. During the process, yes, and it's interesting enough, because during the process you can film what is up and down. And by using like hyperspectral cameras, you can understand where stone is, where coal is, you know, and you will set your digging team to a specific location. But UAV is not only a way to get data. We can get data from many other sources. One source is like undersea inspection. We get like pipelines which are on the seabed. And one example from Australia, they make a filming of roughly 8-12 hours. And then it took 4 months for one engineer to get through the video, to make identification of defects, and to make reports. 4 months. We've done a pilot, and basically these 4 months would become probably a day or 2. Another example is we're talking about, say, refineries, big tanks, which should be inspected from inside out, or those like high-pressure vessels. Today, what's going on, you open up a vessel, the person, again, puts a uniform, gets inside, uses lighting and check conditions, and then try to report and remember where it was. Okay, here's scale, here's rust, here's a hole. What we try to do, we try to put like a robot inside. Robot take pictures or videos. We know exactly the location of robot, and then we use this video and automatically process the video. And then the video shows you which is a good surface, where we got some kind of like a scales of rust. It's done automatically, no risk for the person. Yeah, I'm not sure if you like this feature or not, but you know, it will be coming to a certain extent. Just a few more things before I finish. These 9 things which you just saw would raise up a couple of concerns. How are we going to manage these kind of things? Is it secured or not? The answer clearly is it should be secured. But today we have at least 4 groups of risks identified. First of all, your drone might get a connection link. and just flies away. You don't control it anymore. Another one is the line can be jammed or line could be hacked. All four risks to be considered. For the last 10 years, there was a huge progress in terms of developing drones and software to operate drones. Now, for the last 1-2 years, security becomes an issue. A few months ago, it was a report made by, I think, a US military forces. They managed to hack drones from Israel, which is the most secure drone, which means this risk existing today still. More attention to be paid, how to operate the drones, how safe drones are. But let's make a jump for the next 5 years. You've got a mission planner, and you've got a dozen of drones of different types. Your drones are sitting there. They have fully charged batteries. In the morning, the person operator comes in. It just start navigating where each drone should be going to and what this particular vehicle should be taken care of. Okay, one drone will go to check, inspect some kind of a piles, which will say 10 miles away. Another drone will go to make inspection of a border, to understand if there is no unauthorized access. The third one will go to check, what is going on the project place. Nowadays, it's much easier to make a control of project because, for instance, we got a very good case with a client who made order to cut trees to free up the right-of-way for power lines. And they signed agreement. They took money and say, yes, reported, we are done fully. They fly a drone second time, make comparison, what has been done, not yet started. It's quite interesting. Then you've got your mission planning, yes, and you've got one big board where you can control what is going on. You can see all the risks. You can see sometimes video which is capturing online. And this is one step. Just imagine next step. Drones are coming back after completion of operations. They've got back in full automated mode. They sit down, they landed on a small piece of, I would call it carpet, chargeable mat. And they will recharge batteries. And they're ready to take off in next 5-6 hours, which means the process would become fully automated. Again, this is coming probably a bit more from the future, next 3-5 years, but it definitely will come. I don't want to scare you. I want you to get interested. But if you have any more questions, I would be happy to answer those questions now.
Saa kysyä myös suomeksi, jos tuntuu, että haluaa kysyä suomeksi, niin käännetään. Saa kommentoida.
Are you scared with the video?
Yeah, everybody got so scared. Well, I could ask one question for starters. So in the video we saw that the balloons were quite fatal for that drone.
Unstoppable by balloons.
What kind of weather conditions or some other surprising conditions would be challenges for using drones?
That's a typical question, and the typical answer is the same conditions applied for small aviation would be applied for drones as well. Because, if you have planes which could not take off, the same would go probably for drones. The good thing is, when you crash the plane or when you crash a helicopter, first of all, it costs you a lot of money, but what is the most important part? It costs lives of people. When you crash a drone, it will cost you probably a few thousand euros. Another thing which is very important, it depends which type of vehicle platform to use. Because today we got 3 platforms. One is multi-rotor machines, the one which you saw in the video. Then the second one is the fixed wing, like a small plane, and normally it starts off from catapult. And the third one is convertible. Basically, it got engines like all propellers, which could rotate in different ways. You can manipulate with those ones. It can take off as a multi-rotor machines, as a drone, but then change the position of propellers and will fly as a small plane. It depends on the task which would be assigned to an individual drone. For instance, if you are making a small inspection on site, let's say a couple of square kilometers, this machine would be enough. But if you're making inspection of pipeline or power line, this is not enough because it could stay in probably like 40 minutes, 1 hour. And you know, like if you have hundreds of thousand kilometers to be inspected, you don't want to play every half an hour, 1 hour, you know, you want to run drones. You want one drone to fly and cover hundreds of kilometers. And for instance, in our pilot, we've been using a fixed wing. The fixed wing could stay in the air up to 8-10 hours, which means it could cover roughly 600 to 800 kilometers during one task, one day. Good?
Thank you. Other questions, other comments? Yes.
Questions on extensions, the trickiest ones, yes?
Do you know that electric companies in Finland using this kind of technology today in the winter time, checking the power lines and the trees that are falling into the power lines?
It was a couple of pilots, trials with a local company, and they tried to make an investigation of vegetation. That's exactly what I showed on my map. They tried to make an investigation how close trees are to the electricity power lines. And the technology been using is LiDAR, laser scanner. In my opinion, this is probably the best technology because it gives you the huge cloud of dots, and you can build or rebuild very good 3D model. On the drawback or disadvantage of this technology, because it's very sensitive to mechanical damage. You've got laser beamer, which like scans all the time. And you know, like we send the request to main producers of those beamers and ask, can we install this kind of equipment on our fixed wings, drones? The answer was yes. How many takes off and landings you will guarantee? Answer was 2. 1 takeoff, 1 landing. That's it. The reason is very simple. When this small machine, small plane takes off, the pressure could be comparable when the ship goes to space. It could easily be from 2 to 4.5, 5 G. And it can easily destroy mechanical components of a laser scanner. That's why what we've done, like 3 years ago, when we started R&D Center, we make a comparison. If I can use simpler solutions, simpler sensors like RGB cameras or video cameras, and get the same results. And basically, as we proved with our feasibility studies and projects with our clients, it could be done. And RGB cameras is much, much less expensive, and it's like more affordable and easy to change because it would cost probably like less than 100 euros, 150 euros, depends on the quality. And laser, you know, like a laser scanner might cost you thousands of euros.
Lisää kysymyksiä, kommentteja? Rohkeasti vaan. Jos ei ole muuta, niin thank you very much, Vladimir.
One more.
Just wait, I'll bring you the microphone.
Okay, hello. One question related to flying inside the buildings or big buildings. There are a lot of different kind of sensors that are available and probably and to use to guide the drone inside, but how much that it's used nowadays, or is it in the future?
Yes, thank you for the question. Normally when using machines, use outside, and you fully rely on GPS. You make like landmarks, or you make like GPS points, and you fly your drones, so it's easy to do. With our solution, we try to make accuracy as much as possible, you know, as accurate as possible, to make a detection of a position in space in a very accurate manner. We got 2 or 3 different methods simultaneously to improve accuracy. Because, you know, some of our clients have told us the accuracy of ±1 meter is not enough for us. We should have ±10 centimeters. It's like this, yeah. And today we've been using, like, again, different methods to bring it back to a range of like 5 to 15 centimeters, which is acceptable. But then comes the question, like, can we make inspection within manufacturing facilities? And this is a great question because, you know, like if you have like construction places, like constructing new buildings, new manufacturing plots, you would like to get inspection what is going on, you know, how fast you're developing your projects compared to original plan. Then you can make like sort of like a laser scanner and compare it with the original plan and you see a difference. Are you behind or are you ahead? There is there are things which start developing over the last 2.5 years, 3 years, how to make navigation within a building. Definitely there is no GSM coverage, which you would rely on. But there are a couple of companies which start developing solutions which gives you sort of intuitive connectivity, intuitive positioning for a drone itself. More like it's putting more intelligent on your drone. And basically what it does, basically the drone is like a Google cars. Basically you can maneuver your car. The car knows exactly what's going on. There is a bus ahead, you know, it scans the position. Basically they try to do exactly the same. Of course, today there are a couple of startups which we've been looking for, and they try to make a solution how to navigate drones within closed space, like manufacturing facilities. I would say not yet reliable, not yet, but I believe within probably 1 year, year and a half, the solution will be in place. And again, this is a great solution because there are sometimes we get a request, make an inspection inside, and they're talking about, let's say, steel manufacturing, refineries, you know, big places where a lot of like heavy stuff, and you can easily damage equipment, you can easily damage people, or you can easily damage the copter itself. That's why, you know, like we want this solution to become more ready, you know, like really robust. But probably within next year it should be okay, should be fine.
More questions, more comments?
Yes, one more.
Are there privacy issues, drones capturing data they shouldn't be capturing? People?
Yes, yes.
And how do you cope with the privacy?
Well, today I would say it depends very much on the country. First of all, we made a couple of studies, and then there are two issues. One, legal issue, whether you can fly at all or not, and then second issue, how to deal with information. The first issue is like really interesting because, you know, like in most cases, you're allowed to fly when you maintain so-called the light of sight, when you can see a drone. We got a very good joke in Australia. They want to make inspection of plantations, and you know, plantations are really huge. And, you know, to make inspection of plantations, they tell, like, if we got this kind of rules, you have to see your drone when drone flies. Basically, what you can do, if you got a coast like this, you will put like a person every 2-3 kilometers, and then the drone will be always in the line of sight of one person. Well, of course, this is a joke for sure. In a way, like Australia probably is one of most advanced countries allowing to fly beyond visual line of sight. Sorry. Like in our case, which I make example with Russian state grid, we use drones which flies like for 600-800 kilometers. And basically, first of all, comes the issue of security. You don't control it anymore because, you know, like you can control and see what where drone is, and you can take data in from drone. When you maintain a radio control, which is, let's say, 5, maximum 10 kilometers. But beyond this, you know, you just get information probably from satellites. And that's why, like a UAV manufacturer, they put a lot of things in pressure, you know, that they will be safe enough. Like safety is number one. This legal, what is captured, number two. For safety, for instance, they've got like they install from 2 to 3 GPS, small GPS antennas, you know, 2 used to detect position correctly, to make correctness, and third one used, you know, like if it crashes somewhere in the forest, it starts sending a signal, positioning where drone is. You can go to pick it up. Those bigger machines, like a small planes, it could be, we'll say, weight on average 20 to 40 kilograms. It's like a small and medium. There are heavy machines, probably 125, 150 and more. Those got the parachutes. If anything will happen, you know, they open up a parachute and start like sliding down, you know, in a nice way. And this is like on security. On legal, definitely there are restrictions which are set by different governments. Cases from the US, you know, they've been using drones to make images of landlords and houses. Basically, if you're gonna sell your house, they just send a person with a drone. They make like a real nice 360 degrees pictures of your house. And when you make an announcement on the web, you will see your house, like a future house from different recurses. You know, that's a really cool feature. One thing which happened once, the person when taking like pictures and images, he didn't notice the person, the neighbor. She was like laying down naked and taking like sunburns, and these pictures were shown on the web. You can imagine how much hassle it was. Yeah, today, it's something between lines. Regulation, especially in Europe, it doesn't have very precise things. What regulation says today? You are not to fly 5 kilometers, 3 kilometers closer to the airport, full stop. Yes, of course, when you're landing on a plane, you don't want to see any of the drone killer with a sword. But this basically it. Then, of course, like in the US, especially in California, you've got some extra rules which will apply. You're not allowed to cross a border between neighbors. It's interesting because we have like another thing which is called like a video analytics, and we've been using CCTV cameras, which again capturing some people, faces, etc. What we do, we take a face, but we don't save a face that which this face could match to the person. But we take a digital stamp. Our system would take some physical parameters, like position, distance between eyes, shape, nose, these kind of things. And then this digital stamp will be saved instead of face itself. This is the way how we try to tackle future problems. But today, yes, this is like very correct. And government not yet ready to comment how to do. Otherwise, they have to block completely the use of UAV. But very good question. Thank you.